Today in this lecture we will discuss about complex number. So first of all, the presentation of a complex number is of the form x plus eta y. Here x is a real number and y is a real number, and the value of eta is given by under root minus 1. For example, z is equal to 1 plus 2 eta, z is equal to 1 plus root 3 eta. Now we will discuss some properties of complex number. So first property is conjugate of complex number. So if we have a complex number z is equal to x plus eta y, then its conjugate is given by x minus eta y. So just change the eta by minus eta and we will get the conjugate of a complex number z is equal to x plus eta y. Now next definition is modulus of a complex number. Modulus of a complex number. So for a modulus of a complex number, it is denoted by mod z is equal to mod of x plus eta y, and it is defined as the non-negative number. Is a non-negative real number given by mod z is equal to under root x square plus y square. Now next definition is modulus argument form or polar form, or we can say trigonometric form. Modulus argument form or polar form or trigonometric form. Of a complex number. So what is it? For a modulus argument form, every non-zero complex number, that means z is equal to x plus eta y, and it is where z is non-zero. So we defined it by z is equal to r cos theta plus eta sin theta, where r and theta are both real numbers. So r and theta is belonging to real number, that is x. If we put the value, then we will get x plus eta y is equal to r. We can write in the form of e eta, r e eta. This is a expression for e eta. So here angle theta is the inclination of the number z. So how if we represent it graphically, then how we can say, if this is the x-axis and this is given this is a y-axis, and we have a z is complex number which is non-zero, then the inclination of this number z is from the x-axis is theta, and always it is measured in radians. This inclination is measured in radians, and from the positive real axis. We always measured it from the positive real axis, and counterclockwise. That means you have to take the direction from in this direction, counterclockwise. And negative when measured clockwise. That means if you take the direction in this way, then it is negative. So it is denoted by theta is equal to argument of z. Now next definition is principal argument. Principal argument. So as we talk about the theta argument z, it is argument z is this symbol is a representations of a set of value, represents a set of values. But the argument theta of a complex number that lies in the interval. So if we take this theta, which is this value is the theta is equal to argument z. If we take this theta in the interval minus pi, theta is less than equal to pi, then this value is called principal value of argument z. It is called principal value principal argument of z, argument of z. And this argument represents a set of value, but this principal argument is unique, and it is unique. So argument z is that is argument z, that is minus pi and less than equal to pi. And with the help of this principal argument, we have the set of values argument z is argument z plus 2n pi, and where n is 0 plus minus 1, that means integers. Now some other properties of complex number is like if we take conjugate and then again conjugate, then what is the value for a z? As z is equal to x plus iota y, and if we take its conjugate, then x minus iota y, and again if we take its conjugate, then replace iota by minus iota, and then minus, and minus becomes again plus. So x plus iota y, which is equal to z. So this property states if we take conjugate 2 times, then it again equal to z. Now the second property is that z plus z conjugate is equal to, that means x plus iota y plus x minus iota y, then these will cancel out and we have 2x, and 2x is the real part of the z. So it could be written as 2 times of real part of z. And what we will have if we take z minus of z conjugate, then x plus iota y minus of x minus of iota y, then we have x plus iota y minus of x and plus of iota y, and we have 2 times of iota y, and y is the imaginary part of z. As we have z is equal to x iota y, this is the real part of z, and this one is the imaginary part of z. So this is equal to 2 times imaginary part of z. Now third property is what we have if we take z minus z conjugate is equal to 0. Let's do it. Z minus z conjugate, that means x minus iota y, and putting the value of z, x plus iota y, and minus x minus of iota y, then x plus iota y minus of x, minus minus plus iota y, and this will cancel out, and we have the term 2 iota y. That means we get only the imaginary part. And what we could say, now takes z minus z conjugate is equal to 0. That means 2 item y is equal to 0, and this implies y is equal to 0. So that means imaginary part is equal to 0, then z is equal to x. That means only pure real part is here. So it is a purely real. If and only if we can say that if we take z minus z conjugate is equal to 0, then it gives only a purely real number. Now what we have, if we take z plus z conjugate is equal to 0, then what condition comes? So here x plus iota y plus x minus iota y, and put it is equal to 0, then 2x is equal to 0. This implies x is equal to 0, and so in z, if a complex number is x plus iota y and we put x is equal to 0 here, then what we will get? Z is equal to iota y. That means we have only a purely imaginary number. Or what condition could be right? 0 or purely imaginary number. Yeah, if we take here y is equal to 0, then it is a 0 number, and if we take a non-zero y, then it is a purely imaginary number. So for y 0, z is equal to 0, and if we take y is not equal to 0, then z is of a type z iota y, which is a purely imaginary number. Now what we will have if we multiply z and z conjugate? So z is equal to x plus iota y into x minus iota y. Then what we will have? Then it is x square minus of y square. That means iota y square, and then x square minus this value equal minus of y square and x square plus y square, and it could be in the form of modulus of z, because modulus of z is equal to under root of x square plus y square, and if we square on both sides, then mod z square is equal to x square plus y square. So it could be written in the form of mod of z square. So this property is z into z mod conjugate is equal to mod z of square. There are some properties for a complex number. You can prove this property by yourself.